HPCC Systems presents HPCC for Managers. Lesson 9, Using a ROXIE Cluster. In this lesson, we're going to look at first, what is ROXIE? What is ROXIE used for? How does ROXIE work? Deploying and publishing queries to ROXIE. Working with data and index files and meta keys in ROXIE. And the typical flow of how ROXIE runs a query. So what is ROXIE? Again, ROXIE is known as the HPCC Rapid Data Delivery Engine. It is a number of machines or computers connected together which function as a single entity, running on each node a farmer or server process and a slave or agent processes. This example shows a 5-node ROXIE to your right, and in the typical configuration, each node is configured to be both a farmer and slave. However, in some specialized configurations, it may be preferable to have some nodes acting only as slaves and some only as farmers. Notice also we have data channels shown here, channel 1 through channel 5, and the data is replicated across different nodes. So the data that's contained on channel 1 is replicated on the second node of the D drive. So, ROXIE is a massively parallel querying processing supercomputer with a structured query engine, which uses disk-based indexed data sets, and pre-compiled repeatable queries. It has a scalable retrieval engine allowing high throughput and millions of users receiving sub-second responses. On an average 100-node ROXIE, with 30 threads on each node, the average response time being 1/4 of a second, that gives us 12,000 queries per second on a typical 100-node ROXIE. It also has built-in redundancy. Copies of data are stored on 2 or more nodes. Any peer can deliver a task for a channel, and there's high availability. The ROXIE cluster can continue to perform even if 1 or more nodes fail. Now, it's also important to know that we have backups across many locations at LexisNexis, including Boca Raton, Alpharetta, and Miamisburg, Ohio. Now, in the event that a plane would crash into our Boca Raton data center, there would be an instant switch which would kick in our ROXIE cluster in Alpharetta. And if something went wrong in Alpharetta, our cluster would kick in Miamisburg. So we always have backups available. If anything goes wrong, we want to make sure that ROXIE is available to our customers 24/7, 365 days a year. We had a recent ice storm in the Atlanta area, for example, and operations maintained without a hitch due to our wonderful disaster recovery team. As a manager, you should know that and feel confident that the hardware and the systems behind the information processing that we do at LexisNexis is rock solid. So what is ROXIE used for? Well, ROXIE provides high-performance access to data by running searches against massive data sets. It is normally used for searching using indexes previously built on Thor. It can deliver thousands of standard search results per second and uses multiple threads for efficient multi-user retrieval of data, uses sophisticated indexes, including range of values, phonetics, compound indexes, multivariate keys, and keys that are built across multiple data sets. It can also perform full or index scans of memory-based files, volumes of structured searches, and full text rank Boolean searches if needed. Now, here's how ROXIE works. Each machine runs a farmer process and a slave process. The farmer process accepts queries and returns results, and combines the results from multiple slaves. The slave process stores the data and delivers selected data to the farmer on demand. The farmer process will wait for a request, and when a request is received, the farmer determines which slave nodes have the appropriate data using the meta key. The farmer sends a portion of the query to those slaves and waits for the results. When all the results are received, the farmer then collates the results, performs any additional processing needed, and then finally returns the result set back to the requester. Now, how do we get a query to ROXIE? How do we publish our queries? Queries that have been compiled using the ROXIE target platform may be published to a query set using the ECL Watch. ECL Watch is a web service running on an ESP server. We access ECL Watch via its web interface or by using the command line interface. It submits ECL code to an ECL server and agent which compiles it. Then one of the farmers in the ROXIE cluster will receive the compiled ECL source code or the query, other information about the query, and in that information includes the location of one or more of the compiled shared library files, physical location of the data, physical location of the index file parts, and then the farmer sends this information to the rest of the farmers in the cluster. The cluster copies all needed data files from their remote locations, which may be a Thor, ECL agent, or even another ROXIE. And finally, when the cluster is aware of the query, any farmer can execute it on demand. Now let's talk a little about the data and index files and meta keys that are part of ROXIE. Queries can access data and index files referred to in the ECL code, either from a remote location, which may be another Thor or ROXIE using a SOAP call, or by copying the file to the appropriate slave nodes. By using the remote copy until the copy is complete. In other words, there'll be some parts of the query that will use the data sets remotely until the data has been completely copied over to ROXIE, and then it will switch over to a local mode. Index files also have an extra file part known as a meta key. And what this means is meta keys are often called the key of keys. It's like an index in the back of a book. Each farmer always stores a copy of the meta key. And meta keys are very small because they only contain one entry per file part. Now let's look at how ROXIE runs a query. When a query running on a ROXIE farmer requires a value from an index, the server uses the meta key to determine which parts of the index might contain the value. Using this information, it can tell which channels to send a request to the agents on. And only agents that hold the relevant data will respond on those channels. One agent from each channel will respond to the server with the information needed, and the agents on each channel coordinate between themselves automatically to ensure that exactly only one responds to the farmer. So you've now completed a look at using a ROXIE cluster. You should now know what the cluster looks like, what a ROXIE cluster does, and how a ROXIE cluster works, and how our queries are deployed to a ROXIE cluster using the ECL Watch, how the data files, index files, and meta keys are accessed, and finally how ROXIE runs a typical query. This concludes our lesson on using a ROXIE query. When you're ready to continue, proceed to Lesson 10, which talks about spraying and despraying. Thanks for watching.